Welcome, everyone. Thank you for attending our talk. My name is David. This is Sean. And spoiler alert, we both work for Pivotal.
Today we're going to talk about some visualization, what we did to kind of frame the problem, the value that we get out of our solution, which is TBD named, how we framed getting to the solution. We're going to do a quick demo, then we're going to give you guys a chance to ask some questions.
The team.
So I'm Sean Keary. I'm the Minister of Chaos at Pivotal. I've been working with Cloud Foundry for about 4 years now. Very interested in the operations side and snowboard instructor in my spare time.
I'm David Crawford. I started making websites when I was really young in my teens, and it just kind of snowballed from there. I have worked from development to operations to infrastructure, the entire gamut, and I believe this experience prepares me well to endorse site reliability engineering, which is a practice I like to evangelize and bring to our customers.
And then Andrew Wood, who's unable to join us, was detained at the border. The only Canadian hockey coach who has all his teeth, helped us with some of the coding. Who are you guys? Any platform engineers out there? Show of hands. Okay, couple. Application developers? Couple less. Marketing people? Okay, yeah, we need some help with naming, please, later. And then friends of David.
That's right, Sean. I invited all my friends to this talk, and I think both of them showed up.
Nice. There's Amber in the background.
Discovery.
Yeah, so we've been exposed at Pivotal to some really great tools. Amber in the back here, if you want to talk about metrics, has been building some great visualizations of application level tracing and performance. And we thought we really need something that's going to be more systemic, right? What can we do to get us a picture of everything that's running as platform operators? So a picture is worth 1,000 words. I came across this picture, or one very similar to it, watching a talk by Adrian Cocroft from Netflix Insight Engineering team. And I thought that would be really cool if we could get something like that for Cloud Foundry to kind of show us these global patterns. As we move into more and more multi-site deployments, multi-region deployments, it becomes a lot harder for us to see what's going on across the board. So yeah, what we're trying to do is build a shared understanding, identify some system bottlenecks, theory of constraints. Anybody familiar with the theory of constraints, right? Find your bottleneck, exploit your bottleneck, and focus on the bottleneck. Creating that observability across all your applications, all your organizations, and all your foundations.
Root cause analysis. Let's face it, reproducing problems is hard. That's why it's a lot easier if you have a representation to guide you. Certainly, there's also some excellent use cases here for training and education. I wish I had a tool like this to take with me to all the dojos of the past. It really would have helped with that eureka moment that, I've got it, I understand how it works now. Like Sean said, a picture is worth 1,000 words. This could be a useful tool for validation of assumptions. Did you make changes to your capacity? Did you make changes to your foundation? This is a good way to check and see if those changes had the effect that you were looking for in your foundation. This is also a useful tool for traffic and network modeling. You could technically take the data coming out of your live foundation, multiply it times 2 or 3 just to see what that would look like in this modeling tool to give you an idea of what that load test would look like before you even run it. And lastly, there's some filtering as well. Because foundations can get rather big, there is some flexibility here to filter on the organization level. So if you don't want to see all the system services, or you don't want to see a testing organization, you don't have to see a test organization or space in your graph. Value.
Yeah, so we focused on platform success in our business, right? The 5 factors, the S's we call them, are speed, stability, scalability, security, and savings. I'm going to touch on a number of these things that we feel are going to be assisted through this visualization tool. So if I look at most people's backlogs, you guys all have backlogs, right? I see two things. The first is technical debt, right? We've made some decisions to skip some of the stuff that needed to be done to get other things done, right? So this affects our stability and our scalability, right? As Dave talked about our reliability engineering practice, what we want to focus on is performance optimization and platform reliability. So through visualization, we hope to gain some insight that assists us in these practices. The second thing we see in those backlogs, right, that causes all our technical debt is we want new features, we want them right now. You guys don't get that, do you? So speed and agility, right? How can our platform deliver new features? How can our application developers deliver new features? How can that marketing guy over there develop new features, right? The last piece that's near and dear to my heart is fault injection. Not in a lot of people's backlogs, but I had to bring it up. So how do we continuously test our security and the stability of our systems while minimizing the impact, the blast radius on other systems, right? With Cloud Foundry, Concourse, we can spin up a sandbox environment, slam it, see how it reacts with real traffic with a tool like this.
Framing. I just want to make a quick shout out at this point in time to thank anyone in the community who worked on or contributed to this visceral tool that Netflix has very kindly decided to open source. You have given a really cool thing to the world, and I'd just like to say thank you to those people if they're in the audience today watching. Bouncing off what Sean said about watching that demo not too long ago, it really inspired us to use this tool and see if we could use it to help build a model of what goes on inside a PAS Cloud Foundry PAS. There are a lot of general purpose visualization tools out there, but we felt that this particular tool was extremely well suited to solving the problem at hand, plus it was incredibly intuitive and easy to use. I didn't really have to read the documents in depth. I could just look at the sample application, and the data structure was really intuitive. Nodes and connections wasn't really rocket surgery. It's something we could handle and easily bolt together some open source components to build something really cool. Data sources. So if we have a canvas and some paint brushes to paint with, next we're going to need some stencils or some patterns and some data to actually render on that canvas. And there's a variety of different places that we could pull data from. Just kind of off to the left, I see the Cloud Controller API, the fire hose. We could talk to Bosch and get specifics about the Diego cells. We could also reach out to, let's say, external logging systems, Elk, Splunk, or Stackdriver. We could also pull in performance data from APMs like New Relic or Dynatrace. The point I'm trying to get across here is there really is no limit to what you can graph. It's just a matter of how much complexity you want to put into the code. But for the purposes of visualizing the platform, which is the goal of this particular prototype, we decided to start with the Cloud Controller API and the fire hose. So we took an off-the-shelf app metrics nozzle application that reads a list of applications from the Cloud Controller on some polling interval. And it also subscribes to the fire hose, and it decorates that application structure with metrics coming in from the fire hose. So this is where we get our picture of what's going on in the Cloud Foundry platform. Finally, the third step is putting it all together. So we needed to write some kind of adapter that would take the JSON objects presented by the app metrics nozzle and rewrite them into the data model that Visceral is expecting so that we can get a pretty graph out of this. And this is really the only portion of the system that we had to write by hand. We decided to do it in Python because of how expressive it is and easy to use, and it's only about 325 lines of code. All right, I've put together a little diagram here to explain the architecture of how it works. So here we have our platform engineer. He's happy, but I think he could be happier if he had a pretty picture to look at.
Or a nicer computer.
Or a nicer computer, but hands up if you used one of those before. Quite a few. So the first thing we do is we reach out to the Visceral UI, and we grab the node code, and it runs in the browser. The browser makes an AJAX request to our adapter written in Python. The adapter then needs to go out to each instance of the app metrics nozzle and get some live real-time information from each of our foundations. And all you have to do is install an AppMetrics nozzle in your foundation, and this can scale to as many foundations as you wish to visualize with our tool. Finally, once the adapter has everything it needs, it can send it back to the browser, and the browser can render us a pretty picture. How to classify errors. This is really the most important part of the process, determining what to classify as errors. And I want to stress that there is no right or wrong answer here. It's all a matter of what is most correct in the context of your application. For the purposes of this prototype, we decided to classify any 500 series HTTP error from the routers as an error. But I'm going to suggest that in a more real-life production scenario, that's probably a bit of overkill. Pulling from my SRE bag of tricks and thinking about SLIs and SLOs, we really want to pick indicators that are meaningful to real errors, because we don't want to be chasing our tail over problems that aren't really problems and aren't causing our customers toil or frustration. So if your app developers are nice enough to write log messages that very cleanly and distinctly identify error conditions you need to be worried about, like a dependent service down or something that's not in the right state, you can process those log messages in the Firehose and react only on very specific indicators. But for the purposes of the prototype, we needed to make sure that the errors are being reported somehow. So it's all a matter of what you interpret as an error in the context of your application. Finally, decorating the visceral graph with notices. This is a neat little feature of the tool that allows us to decorate nodes and connections with warnings that will draw our attention to places where things might be going a little bit sideways. For the purposes of this prototype, we've implemented a couple of notices. The first one is check to see that the instances are in a running state. Make sure they didn't crash. We also have 3 predefined thresholds for container CPU, % memory used, and % disk used in the container. And all of these we think are early warning signs that perhaps something could be going wrong in the container or your app isn't quite running the way you think it is. Time for the demo.
And we recorded the demo because I don't trust the demo gods.
We don't trust the Wi-Fi. Everyone turn off your phones, please. So just to kind of set up the context of what we're about to watch here, we are simulating a failover between a primary and a secondary foundation by running load tests on 2 separate foundations. So let's begin. In the center here, this node represents the source of the directed graph. This is the internet, and this is where all the traffic originates from. Down in the lower left-hand corner, this node represents our primary PCF foundation, and this is going to handle the lion's share of the traffic for our application under normal conditions. In the upper right-hand corner, this node represents our secondary foundation, which is a passive site that we only use when the active site is in trouble. And this is a very common active-passive multi-region, multi-foundation reference architecture. So we're going to start the load test here, and we should see something start to flow. Here we go. Traffic is flowing from the internet to our primary foundation. It's handling 100% of traffic. No errors so far. So far, so good. I certainly hope it stays that way. Uh-oh. I can see some red particles, no errors. Sean, did you do something?
No.
Are you sure?
No.
Okay. So something must be going on. Let's zoom in to this primary foundation and see if we can get a better picture. This first column on the left has all of the routes. And if we hover over a specific route, it focuses the flow just for that particular route and application, and we can easily identify the members behind it that back-end serving that application. In the center column, we've got the application instances themselves, and they're labeled org/space/appname/instance ID. And you can see already we've got some notices starting to pop up. It looks like there's some high CPU usage in this container. Looks like there's a rather high requests per second on this particular connection. Let's see if we can zoom in even further. Yep, there's the route. There's the application instance with the errors. I don't know if we can fix this as is, so let's fail over the traffic to the secondary site. And then,
And the right-hand side was the cells hosting the containers, right?
yes, at the very end were the cells. All right, it looks like we've begun the failover. Traffic is now beginning to flow into the secondary foundation. So far, so good. Not seeing any errors. Let's start to reduce the flow of traffic to the primary foundation now. Good. All the traffic has now been directed to the secondary foundation. We are fully failed over. Let's have a quick peek inside. And as Sean was saying on the far right, you can see the Diego cells where these application instances run. And we can see all the AIs on a particular Diego cell by selecting on it. That's our demo.
So just to recap, we felt that the platform engineering teams needed a better way or a more comprehensive way to see systemic bottlenecks so that they could practice some of the reliability exercises that they'd like to do. So we built this MVP tool to be named later by that marketing guy. And we need help with this, right? We don't have any time to do this. So if you guys want to go out there and extend it, use Kafka to send the streams, do the JSON transformations, that would be great. Come see David afterwards if you want to do that.
To review, we think that this tool has a lot of great use cases and applications, the most useful of which is identifying noisy neighbors. Pivotal Cloud Foundry is an incredibly powerful abstraction, but every once in a while you have to peer behind the curtain to see how things really work to understand why you're having the problems or the issues that you are. It's also a great visual tool for understanding application distribution patterns. Sometimes AIs are not distributed on Diego cells the way you think they are. Sometimes you may think you have enough Diego cell capacity and the picture will quickly tell you maybe you don't. So that's another great application of this tool. Educational applications, see how it works under the hood. Love it. I want to stress that this is really a complement to your monitoring. It's not a replacement. Once we get replay in place, we'll be able to go back and pinpoint the time when a problem happened, and you can use that to drill down to start looking at the right place in your logs. So when you go to your other logging and metric systems, you know where to go, and you don't have to find the problem first. And finally, I want to stress about the flexibility for error classification. You need to manage the signal-to-noise ratio because you don't want yet another alerting system that's waking you up in the middle of the night when there's nothing wrong. So I think that the most difficult part of tuning this visualizer just right is what do you consider an error?
Right, so it's a matter of tuning that error ratio to the part of the process you're trying to improve, right? If you're trying to do a root cause analysis for something that happened last week, you may change which service level indicator you focus on, right? If you're doing a post-mortem after that, you might want to put in a lovely recording into your post-mortem so that someone can go back and look at it and say, hey, we're having this same exact problem, it looks exactly like that. Resolved, right? For forecasting, that's another solution, right? We want to look at different metrics, CPU, disk usage, the things we looked at today, which are the simple things, right? And then performance optimizations, same thing. You may want to drill down more into the application level as opposed to looking at the whole system level. And again, this is all driven by our SRE practices, site reliability engineering. We can't have a good overview of the site with no insight into what's going on.
Preview for the future roadmap. We work at Pivotal. Pivotal loves to iterate. This was iteration 1. I was always curious what it would look like to take distributed tracing information like that from Zipkin and try and graph it using this tool. So that's something we're going to queue up for MVP2. As I mentioned in the previous slide about data sources, I think that there's more sources of data that we can call into the picture for an even richer experience. As I mentioned before, history and replay. We'd like to add some data recording to this system because no one's going to be watching this 24/7, 365. When a problem happens, you want to be able to rewind it like a YouTube video and watch what happened while you're off getting a coffee. We also want to take a stab at graphing cross-instance or container-to-container traffic. So when your microservices talk to each other, we think that's the next frontier we'd like to graph on the system. And of course, the complement to that is inter-foundation communication. So maybe you've got replication for things like Pivotal Cloud Cache going between your data centers, or your foundations rather, and you like to be able to see that. And of course, I believe it was Topher from the Concourse group yesterday who said eventually a Kubernetes logo shows up on every slide deck. We also want to include Kubernetes and PKS.
So we have the code available. It's all under David's repo, because I didn't actually do anything. Pull requests are welcome. We encourage your contribution. And
definitely the theme of our talk today is we wanted to demonstrate with low effort how one can easily take off-the-shelf components, bolt them together into something really cool. So we hope that we've inspired all of you to build your own visualization mashups for Cloud Foundry and your other platforms. Thank you.
And then on the previous side, it said feedback is welcome on the Spring One app. If you guys have that, that would be great. But now we'll take questions.
Is there any thoughts about integrating like custom application metrics, or maybe like instead of just figuring out 500, that you can define SLOs for specific applications?
Yeah, so the question was application-specific metrics. Are we interested in that? Sure. Yeah, again, whatever can be emitted into a stream, we can convert into the JSON that's going to work with this tool. And we can visualize just errors, not all traffic, right? Visualize the different types of errors, color code them differently.
The nozzle application is processing the fire hose, so if you can emit it, you can respond to it.
Cool.
Just looking for the architecture, I know you guys built it for Pivotal Cloud Foundry, but it seems like it's pretty extensible. It's got like a bunch of things that you're trying to manage, some in there,
Yeah.
some not.
Absolutely.
The question was, is it an extensible architecture? Yes, right? Just build an adapter to convert whatever you need and send it in there. That's why we really liked it.
In your demo, what initiated the failover? Was it the tool?
So it's kind of a faked out failover. We're just running the load tests in a certain sequence where we start the load test on the first foundation, we start it on the second, we stop it on the first. We're really just simulating a production experience. We didn't actually capture a real production experience.
Yeah, we would recommend your metrics tool, take care of that for you, trigger an event in your pipeline to do a failover. Blue shirt? Blue, black? Whatever's the outcome.
Looks like it.
This is GitHub. Look at it.
GitHub, yes. Oh, yeah, you want to go back? Okay. There was another question back there? No? Change your mind?
Well, I was just wondering if you would add this to if you did chaos testing, that you would add this as sort of, hey, here's how the system responds to that chaos testing, and as a way to figure out if maybe your system didn't behave as well as you hoped it would.
Completely, yeah. That's where I thought this would be a great tool, right? Let's see what the blast radius is in our sandbox, and then start moving that out to production-like environments and see if we're right in our predictions that we're not going to destroy the whole system.
Just curious, how long was iteration 1?
About 2 months. 2 months of my spare time. It's not like 2 months of full time.
All right, thank you guys.
Have a great day.